Hey, hello, welcome to the show. It's me, JP, and it's time for JP's product pick of the week. Here we are. It is Tuesday already. Thanks for joining. We have people over in our chats that I'd love to say hi to, so if you're on YouTube, check out the chat because we've got Dave Odessa, Beata Graf Abdel Hagen, Zoe Sherry, Anthony Becara, Dave Odessa, did I say that? I said that. Randall Bone, Anthony Becerra, sorry, I got that wrong. I may have still gotten that wrong. Also, we have a Discord chat. So if you're somewhere where there seems to be no chat, check out that one. That one right there. Look for Adafruit's live broadcast chat channel in our Discord server. If you're wondering where the server is, it's at adafruit.it/discord. Also, if you're wondering about the weird vest, well, that'll be part of today's product thing. This was a costume vest that my son had from a show choir thing years ago, and it has managed to stay in our in the house, in the costume closet. So every once in a while, things like this come in handy for some projects and costuming things. So that's why I've got this getup on, and I am looking forward to showing it to you. Before I go further, though, I'll tell you, you can check out today's product in advance by heading to that QR code, if that's your thing, or to this URL right here, and you will be able to watch this show inside of that product page. This show is broadcast from within the product page. It is coming from inside this house. So you can watch the show inside of there, and if it's something you fancy, you can get a jump start on getting it at a discount. We have a big 50% off discount today on this product pick. You don't need a coupon code or anything like that. You just simply throw it in your cart and buy it before the end of the show or before it sells out, in case it's going like hotcakes. I know we stashed at least 100 of them before the show. And you, somewhere around the time of the end of the show, the price will go back up to full price. So this is your chance. It's a live thing only. We don't have coupon codes for it. You can't do it later if you're watching the show later. Very sorry. It's just a live thing. That's how this one works on this show. So head there if you want to check it out. And before I go any further than that, I've already gone so far, but before I take one more step in the direction of talking about this week's product pick, I am going to ask Lady Ada, a video of Lady Ada from the past, from the way back past and the more recent past, to tell us about this product, both the sort of V2 version of it a few years back, I think 11 years ago, and the V3 version that has just come out just recently. So take it away, all multiverse versions of Lady Ada.
These are the new version 2 Adafruit Flora NeoPixels. They're so cute.
They're so small.
Okay, and here they are in action. Here's a photo of them.
Yeah. Well, actually, it's the version 1, but
yeah.
Enough. So hold on, let me set this up. So yeah, this is the new version 2 pixels. And let me show them on the overhead. I'll actually show that plate sort of like we were demoing before. So this is 20 pixels, and you know they're really small, so they're kind of tough to show. But the cool thing is that unlike the previous version, which had a chip on the back, these have nothing on the back because the chip is actually built into these awesome little LEDs. And so they use a slightly different timing protocol, so they're not backwards compatible, but going forward will be only promoting these. We'll still carry the old version, but I think these are going to be much less expensive because they're only single-sided. They're also less likely to break because there's nothing on the back that is going to get in the way of your fabric. But yeah, inside here, the little black dot is the chip, and we talked about these because we have them in strips. But yeah, so we have them in little pixels, and so these are sewable, and they work great. And Paint Your Dragon wrote a great library for them. It's the NeoPixel library in GitHub. And so you can talk to these with an 8 megahertz or 16 megahertz processor, and they're meant for use with the Flora. And then even though these are not the same version, I thought I would just show the idea you have here, where you have pixels that are, you know, rainbowy and connected together and chained together without having to use more than one pin on your microcontroller. So we'll be doing a lot of cool Flora NeoPixel projects. And one of the great things is with this new version, we can do double-sided electronics here in the Adafruit factory, but it kind of sucks doing double-sided.
Yeah.
Now you can fit all the parts on a single side. Yay!
Okay.
One side.
There's a revision for the Flora NeoPixels sheet. So for a very long time, we were using the WS2811S, which was the first version of the all-in-one NeoPixel LED. And what's cool about that chip is it can handle up to 9-volt DC power, but that chip is pretty much discontinued. So now we've changed out for the SK6812, which is our standard NeoPixel compatible LED. This is the same size, same pinout, same shape, same everything. The only difference is you can no longer use it with voltages above 5.7, 5.5 volts. So sorry if you were happening to power your projects from 6 to 9 volts, you can't do that anymore without a regulator or a buck converter. But in exchange, because I'm no longer using a chip that I have to, LED chip I have to chase after, the price is lower. So I'll drop the price. This is a great deal if you want to have little sewable LEDs. Get them in a sheet, just pop them out and trim them yourself.
Yes, yes indeed. Look, this right here is my product pick of the week this week. It is the Flora NeoPixel V3 sheet of 20. So this is, as you can see here, a sheet from which you will snap out the NeoPixels that you want. These are sewable NeoPixels. You can, of course, also solder to them, but they're perfect for using conductive thread and sewing onto your projects. It can be a hat, a scarf, gloves, a vest, like this case here that I'll show you in a second. Any flexible kind of projects where you've got a need for some conductive thread to pass along the current as well as the data from pixel to pixel. They are NeoPixels that you know and love, so you can use them in CircuitPython, you can use them in Arduino, you can use them in MakeCode, MicroPython, pretty much any way that you can drive a NeoPixel, you can drive these. And they have the benefit of being sewable, so they can be added to projects where normally a breadboard style board or a bare NeoPixel would be kind of a pain in the neck and involve lots of glue and things like that. These are perfect for your wearable types of projects. Let's take a look at the product page here. So here you can see Flora RGB Smart NeoPixel version 3. So as Lady Ada said, the original version actually had a separate chip to drive the LED that was on the backside. Then version 2 got a WS chip that combined that all into the LED package, basically on the front. These are a newer NeoPixel compatible chip. It's kind of our standard now. It's an SK6812. We use those in a lot of our NeoPixel strips and rings and standalones. And so these are snap apart. You can just simply go like this and wiggle a little bit. You don't actually really need scissors or anything like that. And there you go. We've just snapped out a little NeoPixel and it's ready for use, ready for sewing. It is chainable, of course. So as you can see from, let's see, I don't know if this is any bigger here. Yeah, you can probably see it there. Let me do a close-up with my down shooter, and I'll show you what connections you have on these, because they're a little different than our breadboard NeoPixels, our standalone breadboard NeoPixels. So let me twiddle with the focus there. And I will boost the exposure a bit. There we go. So if you take a look at them, you can see on the sides, so the left side you see there's a minus, that's where the ground line will run. On the right side there's plus, that's your voltage, and that can be anywhere from about 3 to 5 volts. And then there's an in arrow and an out arrow, so that's the data line. So you're PWMing with NeoPixel code, go in and then send along the data to the next pixel. These being NeoPixels, they are individually addressable, so they don't have to be all doing the same thing like an analog pixel. They can all do separate things. And in fact, if you take a look here, I have a little strand of them connected up to a gemma with a little battery on there, and I'm going to darken that a little bit. Let me refocus. So here you can see I've got one bare one, and you can see that's kind of blindingly bright. So on the others, I've put a little bit of diffusion on there, some plastic diffusion, so that they're not quite so bright and they have something to light up. In fact, if you take this one and flip it upside down, you can see often these photograph a lot better when you don't look right at them. Don't look at the sun. So if we flip this over, we can see that it's going through a little color sort of cycle fade pattern there. And if we go back actually to this camera, I can turn this on, so I have a little similar sort of situation there. I'm going to turn this light off, where I have sewn a set of 12 of these onto the lapel of this wacky vest. Again, I've put some little plastic diffusers on there so that they're a little nicer to look at. And if you look on the back side, I've got a gemma. Can't point to it backwards. I've got a gemma on here and a little battery. USB plug is still available, so I can plug into that to change the code. And this is all sewn on with some conductive steel thread, so it's pretty easy to work with. And you can see it's equally bright across all the pixels, so I don't think we've lost too much current across our thread there. We have some great guides, by the way, that talk about how to sew your projects. So here's a nice example. This is in fact a gemma. You can see on the gemma we have the ground, D1, and V out lined up pretty much the same way that a set of these sewable Flora NeoPixels are. So you can just run that stitch along there. If you need to do curves and things like I did here, you'll just sort of manage that, but you're keeping them consistent as far as that circuit, so you don't have to cross over them. If you do have to cross over them, you can kind of use fabric as a two-layer board, so you can head ground on the top side and power on the bottom, and avoid any shorts there. So it's actually pretty flexible. It's similar in a lot of ways to creating a PCB trace, except you're doing it with thread. There's a nice tip actually from Some Nice in the chat. Says one nice tip for working with conductive thread is to use clear nail polish to stop the fraying. And that is a great tip. I did do it on this one. You can't really see this too well. I'm going to turn this light back on. You'll see kind of the gray. You might be able to see some of the gray stitches on there. Wherever I had to knot thread, cut it, and move on, I used a little bit of clear nail polish in order to prevent the ends from fraying out. The main problem with that, if you've knotted it, it's not really going to come apart, but the problem is those frayed bits kind of want to touch other wires. So if you're trying to keep things nice and neat, cut them short and hit them with a little nail polish to keep them together. So let's see, what else do we have to say about these? Here you can see some typical NeoPixel code here. That's the code that's running on this gemma down here. And you can use this with any boards, Feathers, Cutie Pies, Circuit Playground Express, Circuit Playground Bluetooth, ESP32 boards that you can do some wireless things with. So the possibilities are endless, just like with any NeoPixel project. If you take a look at this fairly simple code that I have running on here, that's just running through a set of colors to do little comet things. So we can go in here and change these colors out if we want. Let's see, let's just mess with these. Hit save, and you should see here in a moment this will reboot, and now we've got some different little sets of colors running across there. Not a lot to it. It's a NeoPixel. You drive it the way you drive it, but really a lot of the creativity comes in. How do you want to arrange it? How do you want to sew these onto your projects? And then what are you doing with code? Are you using sensors? Some people in the chat mentioned there are some nice ambient sensor projects out there, sound sensing projects out there. You could of course use this with any of the fancy LED, fast LED, any of the projects that do a little more with gamma correction on the pixels and so on. So a lot of options there. The Question from the chat here. Tyeth asks, oh, that's not it. There we go. What's the most you've powered at once on a wearable? And what's the battery size, type, power supply? So I have very little sewing wearable electronics experience. I'm the wrong person to ask. Aaron St. Blaine is probably the best person to ask. Maybe ask during a show and tell or a Ask an Engineer. This is 12 pixels on here. I think at full white we're close to 60 milliamps current draw. So if you do that math and check out what one pin on the Gemma can do, that'll tell you your limit there. You can do things, for example, to reduce issues with resistance. I actually have a full loop, so my ground goes out to. In fact, let me take this. Can I use this camera? Let me see if I can use this camera to show you a little close-up of stuff here. Yeah, that'll probably work. So if you look, I'm going to turn the exposure back up here. This is very yellow cast. Hold on. Goose that color temperature. That's a little more natural. There we go. So if I can, oh, I'm losing diffusers here. Oh, I know what's happening. This is vertical. There we go. That'll help. Okay. So you can see here I've got a ground, a power, a data. Those are actually running through these NeoPixel. There's one where the diffuser popped off. Through these sewable NeoPixels and back. So I have essentially the ground and the power lines are forming a circle. So we have sort of two shorter distances to go and less resistance rather than just like a single run that ends before it comes back to the Gemma there. Battery on here I think is a 350 milliamp hour. So again, I'd have to do some math to figure out how long that's likely to last. Let's see, any other questions? Yeah, 55 milliamp per max on an LED. You could use a outside supply if you wanted to, rather than right off of the microcontroller. You could just have a shared ground and data and then have a completely separate battery pack. Like a 3 or 4 AA battery pack would be a really good way in your pocket to power something like this a lot longer. Let's see. Zoe Sherry says, my plan's to use these in a wood-stained glass project to make glowing vines. Ooh, that sounds really cool. Yeah, so these are, you know, not just for sewing. In fact, this example here, I used some silicon ribbon wire. I was thinking of doing kind of like a bracelet type of thing. So you can solder to it just fine and make nice little flexible projects, or use maybe enamel coated magnet wire, hookup wire. You can keep your wiring really, really minimal if you want. I think you can even use these with conductive paint, like the, oh gosh, what's the company who used to make that? There was a conductive paint company. But there's conductive pens. You can depending on the resistance and how short the run is, you can use a lot of different types of wiring methods here. All right, let's see, any other questions? Yeah, if you cut down total brightness, the battery can last longer. These are actually at full brightness because I was putting the diffusers on there, and they could come down a lot. These are really bright in person. I was just trying to find the right brightness for the camera with diffusion on top. But yeah, you can definitely bring that way, way down. 0.2 is still kind of nice and visible, and that'll save a lot of battery. So excellent point. Let's see, what else? Any other questions? Let me know. You can head right here, like I said, to product ID 1559 to get these for half price. They are, let's see if we still have them in stock. So $12.48 for 20 of them. So that's like $1.40 per NeoPixel, a pretty nice price for, you know, easy to work with, broken out. You don't have to do a lot of work yourself, just the sewing or the wiring. It's all prepped and ready to go. Just pop them out. You can also file down the edges if you want. These have some little nibble, the little fiberglass nibble marks. Just be sure you do it with proper ventilation, respirator. You do not want to be breathing in fiberglass dust, even if you're just using a filer. Serfami4 asks, where can we get the diffusers? So some of you won't be surprised that I have a lot of Lego laying around, especially I've been doing a bunch of Lego projects. These are 1x1 tiles or cheese wedges. They happen to fit on those pretty nicely. You can tell because I popped one off that they're on there, but not great. Oh, there goes another one. So if you were going to do something like this in a costume piece, you'd probably want to glue them down. But they work nicely. These are just white. The white bricks look pretty good as far as diffusion goes. We have some nice guides. Aaron St. Blaine has a nice guide in the Learn system about diffusion for NeoPixels. So there's a discussion of a lot of different materials that are useful for doing diffusion. I think I'm trying to remember if we still sell NeoPixel lens. LED lens. I thought at one point we had something that could pop on top of an LED, but maybe we don't. But Google around for those. You can also use, depending on the size and scale of the project you're doing, ping pong balls work great. Any type of like a thin, light transmissive plastic can work really well. Wax paper is okay. Parchment paper is okay. There's this fun fur stuff that Aaron has used, just putting the LED set back a little bit inside of your stuffed animal or vest or whatever. You can get a nice glow from the fur, just so you're not looking directly at the pixels. All right, yeah, so that's it right there. We can wrap this thing up. This is my product pick of the week this week. It is Flora RGB LED NeoPixel Sheet V3. For Adafruit Industries, I'm John Park. This has been JP's product pick of the week. See you next time. Bye-bye.